Okay, this is Monday, February 17th, 16th. I don't know, one of those days, 2026. So here's a project. We got two projects going on at my son's house. One is put in a sub panel, and another one is to put in a generator outlet in his garage so he can feed his panel with his generator. This is a pretty involved project, a lot of little pieces to it, but this is the part that I'm doing right now, so I'm going to record this now. So I need to get the wires into there. My plan is to use 8-3 with ground NM copper. There's my son's dog whining because he's on a trip with his family. So my intent is this is going to be surface mounted on the wall of the garage, and I'm going to run this through the attic, from the basement up into the attic, over to the garage, down an inside wall, and I need to put it in some type of conduit. I thought is PVC conduit, and I looked at a bunch of stuff on Reddit and asked electricians I know in that, and this is what they said. You take the largest dimension, and it looks like a 1/2 inch. I'm doing that right. And then you figure out the area. So here is my 8-3 with ground NM copper, 0.5 inch diameter, area is pi r squared. So I do that, I get an area of 0.196 inches squared. And then you're supposed to use this table, a rigid schedule 40, and under inches squared, I got 0.19. So 0.19 is too big for 1/2 inch, so I gotta go 3/4. So that's what I wrote down here. I need to use 3/4 inch PVC schedule 40 to run this down the wall, and then with an LB get into here to do that. Not part of the generator project per se, but at the same time my son needs another 120 volt outlet over here so he can plug in his electrical things that he uses by the garage. His current outlet is like buried in the back of the garage, so it's a pain in the butt. So while I'm running this, I'm going to run 120 volt, and the 12-2 with ground NM copper I'm running is 3/8 inch largest diameter. So the area comes out to be 0.105 inches square. And I'm probably going to run that, and that's schedule 40, so 0.105. There's nothing less than a 1/2 inch, so I will use a 1/2 inch conduit for protection for that wire running down in close proximity to this one. I'm going to put a little backer board on the wall there and mount these things for them. Okay, I have to get a couple more pieces together, but this is all part of the generator project, which we're working on. Okay, I think today is February 20th, Friday, 2026. Yeah, so this stuff in here is all part of our proposed solution to put a generator outlet in my son's house. So let's just go over the pieces and see if it still all makes sense. We're going to explain this in stages. So this was the garage wall. We have 3 cleats and a backer board to put on. We're on a 1/2 inch conduit. Then we have clamps for that. 3/4 inch EMT conduit, clamps for that. And we have these bushings that go on the top, and 1/2 inch bushings for the 1/2 inch EMT. And this up here is going to be the ceiling in the garage, so that's going to go up to the ceiling, so you need the wires to go up the surface of the wall and into the attic space so that we can get them to the panel at the other end of the house. Okay, let's do this in stages. So this is my backer board. The 1/2-inch conduit. I'm going to go through couplings to device box, and we're going to put a 20 amp GFI outlet with faceplate in, and that's because he needs 120 volts, 20 amps at that end of the garage, because he really doesn't have anything else. The other outlets are way on the other side buried, so he wants something out by the garage door. So we're going to install this, and I'm going to run that to the new sub panel when that's put in. Okay, so this, we're running NM83 with ground copper. The panel, we bought an interlock to interlock the main breaker and a double pole 30 amp breaker. And then that's going to run down the conduit to the connector. You know, I think I bought the wrong one. I wanted the one on the face. I'm going to have to take this back. That's not what I wanted. Interesting. All right. And then that's going to connect to here. And this one is a 120/240 or 125/250 30 amp twist lock. And why are we doing that? So in the near future, my son is hoping to buy a Ford F-150 hybrid with the custom power thing that you can supposedly backfeed your house, and that will need the 4 wires because it'll be 250 30 amps. So we're making plans for the near future to have that available for him. But currently he has a 120 volt 30 amp straight generator receptacle. So this is going to plug into the generator with a cord that's going to go to a 120 volt 30 amp receptacle. So that's going to be currently, that plugs in there, 20-foot cord, goes to here, plugs in his generator. This 10.3. I'll have to go back and look if it's 8.3 or 10.3. I think it's going to be 10.3. Maybe I bought the right thing. It looks kind of big. Anyways, this is going to connect in here. It's going to go to this plug, which is going to plug into here, so that if his truck is home, he will be able to use his truck with a separate cable. When his truck isn't home, once he buys it, and now until he gets his truck, we can connect this plug here, which will energize this outlet, which will use this cord. Yes, this is 10.3. Let's just, wait a minute. Yep, 10.3 with ground, so that I will be able to connect this one into here, do the wiring I need, and then what comes out will be for the 120 30 amps. And if my son's kind of like a customized special Craftsman generator for RVs dies, or he needs to use mine, which is just a 120 volt 20 amp generator, then I can make another plug that goes from here to just a regular 120 volt 20 amp plug to a twist receptacle, and then he can use the other generator. And if it's one of those cold emergencies, winter emergencies, storm emergencies, where I can't get to the store to buy new ones of these, I just take this end off. I got a whole bunch of the 120 volt 20 amp ones. I'll just put it on, and then we'll run it that way until something changes. Now, in reading up on the Ford F-150 hybrid with the power generator, they said that what comes out, it was designed for a work site. So you drive your pickup truck to the work site and you plug in all your stuff and it works. It wasn't designed to backfeed a house. So in a truck, the neutral and the ground are bonded, which causes trouble because the house has a neutral and ground bonded. So they said options include contact Ford, have them change the software so that the ground and the neutral are not bonded in the car. Open it up and void the warranty and take a pair of pliers and disable it. Disable the ground from here to the truck and leave the ground to the neutral coming down here, still connected at the main panel. But some people didn't like the idea. And then some people said you should install a transfer switch because it switches both the hot and the neutral, and that takes care of the problem. So when my son gets his truck, he can make a decision how he wants to proceed. But at least I'll have the right connector and we'll have the right size wire. It'll be 240 back to the panel, however he does that. And yes, one of the options would have been to go from here directly to here without going through here, but there's another consideration that we had, and this I think is going to be the most best option to use for that other consideration. I think the next step for this is to get the cleats mounted on the garage wall, get the backer board mounted, mount these things, get the conduit mounted, and then we will probably buy wire and run the wire and secure that properly.